In January, defense support covered leaked images of a Russian stealth combat drone, the S-70 Okhotnik-B, in an attempt to assess the validity of Russia's claims regarding the platform. At the time, it seemed clear that the plane likely had the power needed to carry some serious firepower. However, the source of Okhotnik's, or the Hunter's power, is also likely the reason why the platform lacks usable stealth levels, despite Russian claims. Despite some common misconceptions, stealth is not just about avoiding radar detection. In fact, stealth platforms like America's F-35 Joint Strike Fighter and B-2 Spirit rely on a number of compounding designs, technologies, and even operational strategies to delay detection and prevent weapons from locking onto the aircraft. Both the F-22 and F-35 are frequently spotted by low-frequency radar bands, such as those often used by civilian air traffic controllers. But these lower frequencies are almost entirely incapable of picking up on weapon-level locks. In other words, when the Chinese claim they can see F-22s flying in their airspace, they may be right, but they can do nothing about it. Other elements that play an integral role in aircraft stealth include covering the infrared signature produced by aircraft engine exhausts. The F-117 Nighthawk, America's first stealth platform and the first stealth aircraft to ever see combat, was perhaps the first to incorporate carefully designed exhaust slits meant to dissipate heat while the aircraft was in flight. The F-117's F-404 engines also lacked afterburners, which almost certainly compromised the aircraft's ingenuity, and as a result, its maximum speed was lower than that of the B-52 bomber. These two critical elements of the stealth design are critical for the Russian Hunter, as they do not appear to overcome the radar return created by the exhaust outlets of its engines, nor the problem of infrared detection from the same source. When covering this plane earlier in the year, we assumed that Russian engineers meant to fit a shroud over the jet nozzle sticking out at the rear of the plane. But in new footage released earlier this week, the drone is seen flying for the first time with a large jet nozzle. Hot, unshrouded, radar-loving, and protruding proudly from its tail. This first flight lasted around 20 minutes, with the drone flying to an altitude of around 600 meters according to Russian media. Although the video gives no indication of where the flight took place, satellite imagery shows the Hunter parked next to several other notable Russian aircraft at the State Flight Test Center in Russia's Astrakhan region, including the controversial fifth-generation Su-57. Recently revived from the dead, so to speak, with new plans to set production in motion. As the tweet above indicates, the advantage of using armed combat drones is often their ability to hang around for long periods of time. Though after a good look at these drones, it seems unlikely to offer any advantage over most of Russia's fourth capabilities. Generation fighters, due to the size of these drones and the use of afterburning engines, enormous fuel stores are required to make long flights. Simply put, if it's the same size as a large fourth-generation fighter and has the same engines as a large fourth-generation fighter, it's likely to have the same fuel range as a large fourth-generation fighter. Apparently, these new drones are like so much of Russia's other defense efforts, important as a means of attracting attention rather than as an actual tool of war. Russia has long worked to position itself as the weapons provider of choice for countries on Uncle Sam's row list, and is a key part of that effort and maintaining the perception that Russia can keep pace with advanced weapons systems produced by Western countries, such as the United States. In other words, like the Su-57, the Uran-6 infantry drone, the Poseidon Doomsday submarine, and their flying rifle drones, the program is meant to appear more capable than it really is.